All right, so we are getting very close to the end of Unit 10, and one of the grand finale items is being able to balance chemical equations, and that helps us to prove if the law of conservation of matter is being followed. So for this handout, I'm going to work a couple of examples with you, and then you are going to have to finish it out on your own. You can see that there's 15 for you to do. So you really want to make sure that you're paying close attention in these first couple that I work out. When you feel confident in doing these, feel free to pause the video and then just use me to help check your work. So our directions say balance the following equations by writing the coefficients. Remember, that is the big number in front. Okay? If it is already balanced, write AB. A few of these will already be balanced, and those are really nice because then the work's pretty much done, and you just have to say that you know the work's already done, and you write AB beside it. So for number 1, we have a very simple reaction. It is the synthesis of water. We have hydrogen gas plus oxygen gas. Our arrow showing a chemical reaction has taken place, and we make H2O. We make our water. So remember, the arrow acts like an equals sign, so we're going to draw a line there to divide our reactants from our products. In this kind of game of balancing chemical equations, it is illegal, it is against the rules to mess with the subscripts. The subscripts are already set by the laws of chemistry. You can't mess with them, but you can play around with the coefficients out in front, and I definitely suggest that you use a pencil. I know that I'm using a pen, which means I'm going to have some scribbling out. You can use a pen if you don't mind scribbles on your paper. If you'd rather use a pencil to erase, you can. So to start out, we list the elements that we see, and I have hydrogen and I have oxygen. So I'm going to list them in the same order on both the reactants and the product side. And then the first thing we do is we just count how many we see. So on the reactant side, I have 2 hydrogens, and on the reactant side, I have 2 oxygens. On the product side, I have 2 hydrogens, and on the product side, I have an understood 1 here, so I have 1 oxygen. So this step right here is kind of old for us. We've already done that. And again, ignore this random line that showed up on your papers if you got this set of copies. So this step is sort of old. This next step that I'm going to teach you is the new one. We see 2, 2, 2, and 1, and that does not follow the law of conservation of matter. This is not balanced as is. So now it's our turn through trial and error to balance this equation. So we've got to put a number in front to balance this chemical equation. Right now the hydrogens are happy, so I'm going to work on the oxygens. I have 2 oxygens here on the reactants, so I'm going to put a 2 right here for the products. So 2 times that understood 1 is going to give me 2 oxygens. So now my oxygens are happy, but in fixing my oxygens, my hydrogens now increased. 2 times 2 now gives me 4 hydrogens. So now I have to go and fix this side. I have to fix my reactant side for hydrogens. So how am I going to do that? Pretty simple. I put a 2 there. So 2 times 2 gives me 4 hydrogens. So I'm going to kind of step back and check my work, make sure that it all works out in the end. 2 times 2, 4 hydrogens. 2 times 2, 4 hydrogens. My hydrogens are good. An understood 1 would go here. I'm not going to write the 1 in. So 1 times 2 is 2 oxygens. And then 2 times that understood 1 there is 2 oxygens. So by placing a 2 in the coefficients here, and a 2 in the coefficient here, I have balanced this first chemical equation. All right, we're going to do that same set of steps right here. The arrow is where we divide our reactants from our products. This is called a decomposition reaction, where this one we were synthesizing, we were building up. This one we're breaking down. We have aluminum oxide breaking down into aluminum and oxygen. So we have aluminum and we have oxygen on both sides. And we're just going to count how many we've got. So here we have 2 aluminums and 3 oxygens. Here we have an understood 1 aluminum, and here we have 2 oxygens. So we can see from the start this is not one of our lucky ones that's already balanced. We're going to have to do some work here. And I can go ahead and tell you that when you have a situation where you have a 3 and a 2, your best bet is to try to work out the number that both 3 and 2 will go into, and that is 6. So 3 times what is 6, and that's going to be 2, and 2 times what is 6, and that's going to be 3. So when you go ahead and do that and kind of see how that plays out. So 2 times 3 now gives me 6 oxygens, and let's see what that does to the aluminums. 2 times 2 gives me 4 aluminums, and then 3 times 2 gives me 6 oxygens. So my oxygens are happy, and I need to fix my aluminums. I have 4 on this side and only have 1 here, so that's actually going to be a pretty easy fix of putting the 4 right there. So 2 times 2, 4 aluminums, 2 times 3, 6 oxygens. Always go back and check. 4 times 1, 4 aluminums, and 3 times 2, 6 oxygens. So I have now balanced this chemical equation by putting these in the coefficients. All right, number 3, we're going to draw the line where the arrow is. We have magnesium plus hydrochloric acid makes magnesium chloride and hydrogen gas. This is called a single replacement. Basically, hydrogen and chlorine are going out, and hydrogen breaks up with chlorine, and you can see that magnesium swoops in and gets him a new girl, so we make magnesium chloride, and now hydrogen is over here all by himself. That's called a single replacement. So, magnesium, hydrogen, and chlorine, write it in the same order: magnesium, hydrogen, and chlorine. Count them up. Maybe this will be one that's already balanced. We've got 1 magnesium, 1 hydrogen, and 1 chlorine. All of these have understood ones out in front. Feel free to pause the video at any time, though, and work these yourselves, and then just use my video to check. Here we have an understood 1 for magnesium, a 2 for the chlorine, and a 2 for the hydrogen. So we see that we are not balanced. So we got a little work to do. So we need 2 hydrogens and 2 chlorines over here to balance out the 2 that are here. So I'm going to put a 2 right there. And let's see if that fixes it. Got a pretty good feeling that it might. Okay, so 1 magnesium, 2 times that understood 1 is 2 hydrogens, 2 times that understood 1 is 2 chlorines. That's good. 1 magnesium, 2 chlorines, 2 hydrogens. So just by putting that 1 coefficient right here of a 2, we balance this whole equation to make it follow the law of conservation of matter. Next, this reaction should be becoming pretty familiar to you. CH4, do you remember who that is? That is going to be methane gas. This is the combustion of methane, CH4, plus O2. Anytime something burns, you must have oxygen present. And whenever something burns, you make carbon dioxide and water. So this is a classic combustion reaction. It has carbon, it has hydrogen, and it has oxygen. Carbon, hydrogen, and oxygen. We count them up on either side. There is 1 carbon here, 4 hydrogens, and 2 oxygens. Now this side, be careful because there is oxygen here and there is oxygen there. That's kind of tricky. There's 1 carbon, 2 hydrogens, and 2 plus 1, 3 oxygens. Okay? So we've got to work to get this balanced. I think I'm going to start with the hydrogens. There's 4 and 2, so that seems like that could be an easy fix for me. I'm going to put a 2 right there. 2 times 2 is going to give me 4 hydrogens. But in fixing these hydrogens, I have changed my oxygen number. So I now have 2 times that understood 1, 2 oxygens here. And I have to add that to the 2 oxygens here. And 2 plus 2 gives me 4 oxygens. So I have 4 oxygens on this side and 2 oxygens on this side. So what do I need to put in that blank right there for a coefficient? Do I need to put a 4? 4 times 2 would give me 8. That's too many. If I need to get 4, then I need to put a 2, because 2 times 2 will give me 4. So step back. Let's make sure that this works. 1 carbon, 4 hydrogens, 2 times 2, 4 oxygens. 1 carbon, 2 times 2, 4 hydrogens, 2 oxygens here, and 2 times that understood 1 is 2 oxygens, so 2 and 2 make 4. So that one was a little trickier with those oxygens kind of spread out everywhere, but we got it done. And then the last one I'm going to work with you, number 5, before I let you loose, is this one. This is a double replacement reaction. We have hydroiodic acid, HI, plus potassium hydroxide makes H2O, water, and potassium iodide. And if you think of water as HOH, you can see where this is a double replacement reaction, where basically hydrogen and iodine break up, potassium and hydroxide break up, and they switch. K goes with I, and H goes with OH. And that's where it makes HOH, which is water. All right, let's count them up. We have H, we have I, and we have O. We have H, I, and O. Oh, I forgot K. Okay. So let's count the H's. Here we have 2. And how many do we have here? 2. The I's, we have 1. Over here we have 1. The oxygens, we have an understood 1. And over here we have an understood 1. And then for potassium, we have an understood 1. And for potassium, we have an understood 1. So what's it look like we got here? Do we need to do any work? This one is already balanced. You will have at least 1 more of those that you get to find on this paper. Okay? So you're going to do number 6. I'll start you off. Draw our line. This is lead and hydroiodic acid again, HI. It's going to make hydrogen gas and lead iodide. So PB equals, H equals, I equals. Do that for both sides. You're going to count your atoms. This one, see if it's balanced, and then work to get it balanced. You'll do the same thing here. NaCl. See if it's balanced, and then put your numbers in your coefficients to see if it's balanced. Don't forget, there is a back. Your teacher will be around to help you. Let us know if you have any questions.